So what is a variable? It's a memory location. Let me add one more word. It's a named memory location where a value is kept, and that value can change during the course of a program. Okay? An array is exactly like a variable with one slight difference. It is a collection of memory locations known by a name. Okay? The values can change during the course of the program. So the main difference is an array is a collection of values. Variable is a single value. So here comes the question. Okay, if array is a collection of values, then how do we know one value from another? We have a concept of index number. So each of the value is given a number. That number is called an index number. And what's the plural for an index? Indices. Okay. So index numbers are given to the collection of array. So an array is typically a bunch of memory boxes, and it's a continuous. There are continuous memory boxes. It's not like one is here and one is there. It's a continuous memory boxes. So one of the examples that we use here is your muffin tin is a good example of an array. So if I can grab any of these muffin tins, for example, this one, that's a good idea of talking about a multi-dimensional array because it has two rows. If it has one row with multiple muffins can be made at a time, that'll be a single dimensional array. If it has multiple rows, it's a multi-dimensional array. So right now, this is a single dimensional array. So for example, if you have a muffin tin in which 4 muffins are there, and it's one row, you're going to call muffin 1, muffin 2, muffin 3, muffin 4 to distinguish one from the other. Similarly, over here, we have indexes, but the index number of the first array is 0. Simplest definition would be an array is a container that holds multiple values of the same type. Array is a container that holds multiple values of the same type. Where would you use arrays in robotics? Well, it can be used to store the motor speeds if you have multiple motors. And if you want to see what is the speed of each motor and you want to simultaneously maintain all speeds or at least check on them, you can have an array called motor speeds and the size of the array will be dependent on the number of motors you have. It could also be used to store sensor data, and it could also be used to store joystick positions, for example. These are some examples, just so that you can correlate to where it can be used in robotics. Okay, single dimensional arrays. Now notice this, that when arrays are declared, they're declared similar to variables, except for if you look at the very first line, we have square brackets. If I was declaring a single variable, I would write integer speed equals to 40. That's one variable. But if I'm declaring an array of speeds, I will write int square brackets. This is to tell that this is an array speeds equal to new int 4. Now let me explain you this. What does that do? Int is telling the computer I need an integer data type. The name is speeds. It's an array. New is saying I need to allocate more than one memories because by default integer gets 1 memory. And now you're saying I need 4 memories. And I need each memory to be of type integer. So now what computer does, it creates 4 memory blocks. If integer takes 4 bytes, then it knows exactly each block has to be of size 4. First block is 0, then 1, then 2, then 3. Everybody understand that statement? Okay. Now, if I were to give a different value to the variable speed, I will just write, for example, if speed becomes 50, I'll write, okay, speed is 50. Because it's one variable, so it is a single block of memory. But here, I can't do that. I cannot just say speeds. I cannot just say speeds equals to 50. I can't say it because it would get confused. Where would you want me to put 50? Which of the blocks? That's why when you're dealing with array and you want to give it a value, you need to first give the block number. Let's say block 0. So it knows I need to go to the block number 0 and put 50 there. Okay. Now, if you look at the example over here, what value am I putting in block 0? 25. Okay. What value do I have in block 3? 40. Okay. What value do I have in block index 2? 35. And here I have 30. Okay. So you need to give the block number. And what is the official name for a block number? Index number. Okay. That's why you will see when we use loops to go through the array, usually the variable is called I, which is for index. Some people also use a variable called IDX, short for index. Some people use the variable CTR for counter. Okay, so all of these practices have been there for a very long time, and these are just naming conventions. You could call this variable A, B, C, D, doesn't matter, but it's just like naming convention, help people remember things in terms of context. Okay, here is the context I was talking about. Look at my loop. Since all of these are memory blocks and they are in sequence, so that's why I look at my loop starting point. What's the first value? 0. I is 0. I is going as far as, now this is one of the beauties, just so that you don't have to remember how big the array is, we have a built-in property called length. So length will automatically tell you how many blocks are there. Now, look at the operator before length. It says I less than speeds dot length. Why doesn't it say less than equals to? Yes. Because we start at 0, so length is always 1 more than the last index number. Okay? That's why you say, I want to stop before I hit the length. If you do less than equals to length, what will happen? It will give you an error called out of bounds. Anytime you see an array out of bounds error, it means you're trying to get to an index number that doesn't exist. So that's why when you're using length, you stop before the length, and that will automatically be 0 and any number before that. Okay. Now what's going on line numbers 2 and 3? We're displaying an output wheel followed by a wheel number. And we're telling, okay, the speed of the wheel is this. Why do we have I plus 1? Does that changes the value of I? In programming, if you go back to Tuesday, I told you, are these two statements the same? No. What is happening in the first one? You're just adding 1 to the current value of I. You're not changing the value of I. In the second one, you're changing the value of I. So that's a big difference. So what you're doing is, instead of saying wheel number 0, because person doesn't know, index stores 0 through 1 minus length. In real life, we start from 1. So we want to say wheel 1. This is the speed. Wheel 2. This is the speed. Wheel 3, this is the speed. Wheel 4. So we are not changing I. We're just adding 1 to the value of I so the person running the program can correlate with it. Okay? It's pretty much like if you are playing a game, Mario Brothers, and you see the top 10 scorers, and it says next to the first scorer 0. This wouldn't make sense to a lot of gamers. It's like, I am first on the winner. Why is it there a 0 next to my number? Behind the scene, the indexes are 0 through 9. But on the screen, they will say 1 through 10. Just because people correlate with that. Anyway, so let's get this taken care of first. So if you have not yet opened your editor, you can do that. Remind me, you have to get 2 quizzes.
So this is plus these brackets I. So is the I plus 1 or is it I in the form?
It is the same I. What you're doing is you're taking the current value of I and you're adding 1 to it only for display purpose. So when it runs the first time, instead of saying wheel 0 speed is this much, you're saying wheel 1 speed is. So only for display purpose, you're adding 1 to it. But you're not changing the value of I. So if it was I plus plus, then that would change the value of I. Ashish, can you please close the lights? Yeah, thank you. Okay. Everybody ready? So let's start with our. Everything okay in the back? Okay. Speeds equals to new int 4. So what do we call this? We call this array declaration. So the first statement is the array declaration, means you're declaring an array by giving it a name, giving it a data type, giving it a size. So these are the 3 things in array declaration: name, data type, and size. You got to remember these concepts for the quiz and beyond. So what are the 3 elements that are part of declaration? Name, data type, and size. What is the length of this array? Mohammed, what is the length of this array? 4. Index number range. Hamza, what is the range for index numbers? 0 to? What is the length? Okay. And the last index is always 1 less than the length. 0 to 3. I did not hear it. It didn't carry over. You guys talk much louder among yourselves. Okay, array assignment. is now that we are giving each index location a value. So we have declared the array, and we have assigned each of the boxes a value. And to get to the box, we use an index number. And this is a good place for you to use copy paste. So I hope you're not typing each of the 4 lines. Now we will display the array. So for integer I equals to, what should be the starting value for I? 0. I put greater than or equals to. So what should be less? Yes. Thank you. Muhammad, what mistake did I make? I put 3 pluses. So when you run this, you should get an output. Speed 0 is this, speed 1 is this, speed 2 is this, and speed 3 is this. So the count is starting from 0. That was the whole reason of adding that +1 in the example in the PowerPoint, because we do not want to show user 0, 1, 2, 3. We want to show to the user 1, 2, 3, 4. So that's why I put the parentheses, because now I will write an expression, mathematical expression here, I plus 1. And now when you run it, after that change, you will now see speed 1 is, speed 2 is, speed 3 is, and speed 4 is. So it's merely for output purposes, and there is no other reason other than that for that mathematical expression. Only for display purpose. Everybody else got it? Sadik, you got it? Why we put that parentheses there? Okay. Now, let's copy. Let's copy everything that we wrote here and go and hit the plus sign and create main2.java. Paste everything that you copied. Change the class name. Everybody got that? Pasted it. Change the class name. Change the tab name. Now we will learn an alternate way of declaring an array. Declaring a filled array means the array will be pre-populated with values. In order to do that, let's get rid of all of these lines for now. Select all these lines and delete them. Going back to your declaration line, you start with an open and closing curly brace. Open and close, curly brace. Between the curly brace, we will put 4 values separated by comma. This is an example of creating a filled array. This array is, what is the length of the array? 4. Because there are 4 values. First value is index 0, last value is index 3. Everything stays the same. The only difference is, in the previous example, we declared an array, and then we assigned it afterwards. Here we're creating a pre-filled array. Why would you want to do this, and why would you want to do the other one? You would want to do this when the values are already known, and those values will be the starting point for your application. Then you can preload those values when you're starting the array. The other approach is usually taken when you're accepting a value from a source. So instead of assignments, these are usually in a loop accepting values from user. So this approach is usually done when you know the values and you just need to go through the values. Okay, now let's run this. That's it. It'll give you the exact same output. That'll be 4 values, but the logic is much smaller because the array is already filled. Got it, Mustafa? Oh, okay. Now, let's open a third tab called main3.java, and we will paste the first example again. Paste the first example again. Now, in this example, we will accept an input from user. So we are using an import command. We're using a scanner. And let me delete all of these extra lines. So all of these lines will be gone. This is where I will rather write the logic, accept input from user. So system.out.print, enter speed. Speeds 0 equals to scan.next int. Okay. What is the limitation of this code? Yes, Abdul, go ahead. No, right now, the way the code is right now, what is the limitation of this code? It only takes the value for the first index, and that's it. All other indexes, what are their values? 0. Okay. So we will now change the example to accept the input for each of the boxes. Go ahead and run it, just so that you can see how it is behaving. When you run it, it will ask you enter speed. You will enter one speed and hit enter. And then you will see that you will get 4 outputs, where one will be that speed that you entered, and all others will be zeros. Yeah, that is like, I'm done running, so that's an appreciative music. Okay. So now to fix this problem, what we will do is we will write a loop around. I is equals to 0. I should be less than speeds dot length, I plus plus. And we will use a curly brace around this. And just to be a little bit more explanatory, enter speed number one. So made a little change to line number 8. So when I run it now, it will ask enter speed number 1. When I enter speed number 1, it asks me, okay, now enter speed number 2, speed number 3, speed number 4, and then it displays all 4 speeds. What's wrong? Thank you. See, this is the kind of a mistake. What would you call? What kind of error did I make? No, it's not. If it was a syntax error, the code wouldn't run. No, the code wouldn't run. If it's a runtime, it didn't generate any error. It just let the code go through. My output was incorrect. It's a logical error. Okay? The logical error is the error that produces an output. The output does not make sense. So what are the 3 types of errors? Syntax, runtime, and logical. Computer will tell you for the first 2 that you made a mistake, but for the 3rd one, you have to figure it out yourself. So when I now run this example, so I enter 4 values, I get those 4 values back. So if you look at the loops, they're very identical. The first loop's job is to accept the values. The second loop's job is to display the values. Their jobs are different, but they're written very similar. Yes, done. Oh, you have an error? Oh, the reason is you forgot the curly braces on line 7 and line 10. So please make sure that you add the curly braces line 7 and line 10. Because the loop, the body of the loop includes both instructions. It is also possible for you to incorporate an if condition in the middle of the loop while you are reading. For example, you are like, okay, I want to go through all the array boxes, but if the speed of stored in the current box is less than 30, I need to inform the user that wheel number so-and-so is slow. Okay, so we'll incorporate an if condition logic to inform the user if any of the wheel is performing slower than a certain speed. So we are going back to our code. So after displaying the speed, we will have an if condition. If the speed of the current block is less than 30, then display this output. So when you're entering values, make sure at least one of the value is less than 30 so that you can see the output for that wheel to be less slow. How many containers do you see here on the whiteboard? Containers are 2. Okay, there are 2 containers. Each has 3 boxes. So does each of the container has the same size as the other one, right? So both containers are of the same size. So if you have multiple containers of the same size in a program, And if they hold corresponding values, we call them parallel arrays. What do I mean by corresponding values? By corresponding values, I mean, for example, the first container represents student ID, and the second container represents student scores. So their indexes will be 0, 1, 2, 0, 1, 2. Let's say this is student ID 111. This is student ID 112. This is student ID 113. So the score for 111 student is 70. The score for student 112 is 79. For 113 is 99. So since both arrays are of same size and the values in the same location are related values, such arrays are called parallel arrays. Same length, and the values in the same location are related values. Okay, so for example, if you have 4 robots in the first array, and the second array show you the level of accomplishments of each of the robots in the same slot, then it will be called parallel arrays. But if there are 2 arrays of the same size, but the values are not related, for example, the first one hold the student IDs, the second one hold the name of the CEOs of 4 companies, then they're not parallel. They're same size, but they're not parallel because the values are not related. Oh, system doesn't know. You have to code it like that. Okay, so that's where your logic comes in. System have no understanding of the 2 arrays being parallel or not. It's just like the way you code it.
Like code.
Yeah. You can have some parallel and some non-parallel arrays. It's totally up to you how you want to code it. Okay. Now let's get to that. Let's start with main 2. Let's copy the entire main 2 and create a main 4. Copy main 2 and make sure you change the name of the class to main 4. How many arrays we have right now? Only 1, right? We would now introduce another array. String teams equals to curly brace. We'll call this one read crescent full moon okay. These are my 4 teams. You can't say that out loud. The last team's name. The person next to you may think that you're calling that person X. UX, no UX. UX. Okay. Okay. So what we have is that each of the speed represents a team. So 25 is the speed of read. 67 is the speed of crescent. 33 is the speed of full moon. And 10 is the speed of UX, right? Now we will display it. So let's change our output just a little bit. You may be wondering, the output, the loop itself, it is running by the length of speeds. Do I also need to tell to run by the length of teams? No, because remember, there are parallel arrays. They're same size. So loop only needs to know how many times I need to run. Since the size is the same, the loop needs to run the same number of times. Now inside the output, yes. No, say it again. If they were not the same, then they won't be parallel. right? Then there'll be two separate loops, and for each loop, you would have to have different loops. For each arrays, you would have different loops, right? Okay, so now here, I'll display it like this. Team name comes from the teams array. And speed comes from the speeds array. So the name comes from the names array, teams array, and the speed come from the speeds array. So the outputs will be team name read, speed 25. The next line will say team name present, speed 67, and we'll go like that. So you could very well create a parallel array where the first one are the set of Pokemon trainers, and the second one has the Pokemon. And then you can display the trainer name and the Pokemon name. Now here comes the question. Okay, what if the trainer has multiple Pokemons? Then what you would do is you will create a first parallel array with names of trainers. The second parallel array will actually be a multi-dimensional array because each trainer has multiple Pokemons. So it is possible for you to have a parallel array relationship between a single dimensional and a multi-dimensional array, as long as the trainer number 1 will look at the row number 1 for all the Pokemon that the trainer has trained. Okay? So parallel arrays can happen between single and multi-dimensional arrays as well. But did everybody get this? Okay. Now let's modify this one bit more. So coming down here, string cities equals to so now I have incorporated the cities from where these teams are participating from. So I'm displaying the team name, I'm displaying the team speed, and since I cannot fit it all in the same line, so I can just press enter right after the square brackets of I can press enter, and now I can say, okay, city name. It's the same logic. I press enter after the square brackets, and after that, I'm displaying the city name. Yes. Oh, thank you very much. I need a curly brace. I forgot to brace the curly. Not brace. Okay, so when you run this example now, yes. I need a plus where? Oh, here, you're right. Thank you. A plus, a concatenation after the speeds and before the city name. So now it tells you the team name, speed, and the city name. Okay, now let's move on to the multi-dimensional array. As I told you, a multi-dimensional array is like a muffin tin with multiple rows and each row representing a place for multiple muffins. So let's start brand new with main5.java. Oops, main5. main5.java. Public class main5. So for multi-dimensional arrays, you need two sets of square brackets. You need a pair of them. We're going to call this one sensor matrix because we want to store our sensor readings equals to and open and close curly braces, just like this. So let's do the setup for now. Yes. So what we are creating now is a multi-dimensional array. So this multi-dimensional array will have multiple rows. So let's say if I want 3 rows and I want 3 values in each row, that's why I use 2 square brackets. The first square bracket represents rows. The second square brackets represent columns in a row. Okay? What is the index location of the first row? 0. First column, 0. So if I am reading sensor from this location, what is the indexes for that location? Row 1, column 1. So I'll say 1, 1. If I'm reading it from here, what will I say? 0, 2. Okay? Because 0 is the row number, 2 is the column. So you always write the row number first, and then you write the column number. Okay. Now, let's set up these sensors. Row number 1 will have its own set of curly braces, comma. So I'll just call this one row 1, comma. This is my row 2, comma, and this is my row 3. So there are 3 rows. These are the sensor readings from the first row. Sensor readings from the second row, and the ones from the third row. So each row has 3 sensor readings. No comma after the third row. You never put a comma after the last row. But that's just like you never put a comma after the last value within a row. So this creates a matrix of 9 values. What value is in this location? 15. What value is in this location? 14. Okay. Cool. I will need nested loops to run through this. My first layer of my loop will be to go through the rows. So for integer r equals to 0, r less than 3, r plus plus. I will also teach you the length logic, but that's in the next step. Let's first do without the length logic. So this will help me go through the first rows. Then the next loop I have will let me go through the columns in each row. So the first layer of the loop is for the rows. The second layer of the loop is for the columns. Okay, everybody got this? Okay, this is where the output is. System.out.print. Sensor matrix. Row column. I purposely wrote print because I want to display all the sensors for the same row in the same line. That's why I'm using print, not the println. So when I'm reading a row, I want all the values to be displayed separated by space. And then between the two loops, I will create a new line. New line between each row of output. So within the same row, all the values are separated by space, and the values are in different rows. Values in different rows are displayed in different rows. Yes.
Just by doing something about how that fit on like 10, 12, 15, and 19.
But if I display 10, 12, 15, that means I'm locking my program to always display 10, 12, 15. What if the values change? So that's why I don't want to lock myself into pre-written values. I'm doing pre-written here so that we have to write less code. Otherwise, you would be sitting there entering all the values. Okay. Now we will make the slight change of length, which can be done here. R less than sensor matrix dot length. So the length of the matrix, if you just directly call the array name dot length, it will just tell you how many rows I have. So it'll go from 0 through 2. So how will I figure out how many values are in each row? So I can go by the length of that. And then the name of the array.length. That's exactly what I did on line number 8. That will tell me the number of rows. Yes, so what I need to do here is I need to tell the name of the array. And before I call the length, I need to say, okay, go by so-and-so row number's length. Why did I choose 0? Because all lengths are same. I could pick any row number because all have the same length. I could pick 0, 1, or 2 will work the same because all rows have the same number of boxes. This is one way to do. If all rows have the same number of boxes, then you can pick any row number. That'll work. This is extremely beneficial if you are planning on increasing the size of your array. You wouldn't have to change a thing at the bottom. In the previous logic, you would have to go and keep changing all the max length numbers from 3 to a higher or a lower number. But now let's say after I make this change, if I go up here and I decide to make it a four value row. So each row now has 4 values. I don't have to change a thing at the bottom because everything is mapped to the current size of the array. So it will go 3 rows by line number 8, and line number 9 says length of row number 0, and that is 4 now, so every row will read 4 values. Yes.
And mark 0 at the column or not row.
Oh, when you want the row count, all you need to do is tell the name of the array and use the length operation. That is automatically tied to telling you how many rows are there. But yes, now what I need to know is I need to know how many values are in each row. So I can pick the name, I can pick the number of any of the rows for it to tell me how many values are in that row.
No.
No, it only works for multidimensional. This is multidimensional. It has more than one dimension. It has rows and columns. So the first loop is reading the rows. The second loop is reading the number of values in each row. So that's why we put 0 in the second one, because now I need to know how many values are in that row. I could very well, instead of using 0, I could very well just use C, which means whatever is the current value of C. So when I'm running it the first time, the value of C is 0. So it tells me, okay, the length of the first row is 4. Next time I go, it tells me this is the length of 1. Next time I go, it tells me length of 2, and it just goes like that. Oh, my bad. It shouldn't be C. It should be R. R dot length. It should be the length of the row, not the length of the column. So here is another example of parallel arrays. I have one array called motor names. Another one is called motor speeds. So what is the speed of the right front motor? $70, because it's a parallel array. So the first value is the speed of the left front. The second value is the speed of the right front. What do you think this will do? What can you explain this in like a few words? What is this program logic doing? Yes, Daniel.
The bar speed, and then it will say it's overspeed.
Okay, just a slight change in your answer. It will not display the motor speed. It will display the motor name.
Oh.
Okay. So basically what this program is doing, it is going through all the motor speeds. Any motor that is running at a speed higher than 65, it will inform you that so-and-so motor is overspeeding. This is just a code snippet. So these kind of code snippets, you can expect next week that you may be given a code snippet and you may be asked, okay, write in words, what do you think this code is doing? So you would have to assume that there is an array called motor names that has the names of motors, and there is an array called motor speeds, which have some speeds. So that's what it's called, code snippet. It's not a complete code. You look at the code snippet and you try to figure out what possibly this code may be doing. So yeah, so it will basically go through each motor speed value in the motor speeds array. Any value that it finds that is greater than 65, since it already knows the location through I, it goes to the same location in the motor names array and grab the name from there, and then say, okay, so-and-so motor is overspeed. So for example, because there are parallel arrays, so for example, you have two arrays. One has speeds, let's say 70, 29, 66. Another one has all the names like front, back, left. So when you're running the program, it reads the first speed. Is that over 70? The 65, sorry, over 65. It says motor F is overspeeding. Then goes and reads the next one, which is 29. That's not over 65, so it doesn't give any output. Then goes and reads the next speed, which is over 65, so it says motor L is overspeeding. So the output of this program would be that motor F is overspeeding and motor L is overspeeding. That is if I tell you the details. If I do not tell you the details, then the generic explanation. Okay? This is in a multi-dimensional array. How many rows? How many values per in each row? 3. Okay. Now this is to loop through a two-dimensional array. Okay. Now I want you to code this. Here's an activity. These are the values for the two parallel arrays that you will code. One parallel array will be called motor names. These will be the values you will feed. The second parallel array will be called battery levels, and these are the values that you will feed. Okay, so I asked you to create two parallel arrays. One of them has motor names. And the other one has the battery levels. Motor names I gave you are front left, front right, back left, and back right. These are the 4 motor names. The values I gave you are 25, 15, 40, and 18. So parallel arrays, each having the same number of values and corresponding values. Now we need to traverse through the array. So integer I equals to 0. I should be less than. I can pick any of the two arrays' length because they are both parallel. Now I need to check the battery level. If the battery levels of the current location of the array is less than what value? 20. Then I need to inform user. I do not need to inform user if the battery level is equals to 20 or greater, other than a different message. Okay. So if the battery level is less than 20, then system.out.println warning. So-and-so motor battery is low. So motor, battery is low. Battery percentage is battery levels. Otherwise, copy this, paste it. No warning. Battery is okay. And the battery percentage. Oops, did I miss something? Oh, I have two of these concatenation operators. So the front left battery is okay, but front right has a warning. Back left is okay, but back right has a warning. So this is the code, the main logic.